Hello guys, welcome back to the Universe of Tech Up. In this tutorial, we will learn about binary heap and what is binary heap and types of heaps and heap properties, operations on heaps, and how binary heap works. It's all about this tutorial. First, we need to learn what is binary heap. Binary heap is a Binary heap is a complete binary tree that satisfies the heap property. It is typically used to implement the priority queues like that. And explaining that in a binary heap, each node has at most two children and the tree is filled from left to right. And the tree is filled from left to right. This is all about what is binary tree. Next, we move on to the types of heaps. There are two types of heaps. One is minimum heap and second one is maximum heap. First, we need to learn what is minimum heap. In a minimum heap, for any given node, the value of the node is less than or equal to the value of its children. The minimum element is at the root. This is what is minimum heap. Next, we move on to the maximum heap. In a maximum heap, for any given node, the value of that node is greater than or equal to the value of its children. The maximum element is at the root. It's all about the maximum heap. Next, we move on to the what are the heap properties. Heap property in a heap, minimum heap for any given node, the value of that node is less than or equal to the value of its children. Second one is in the maximum heap for any given node, the value of the node is greater than or equal to the value of its children. Like it's a first one is it's a complete binary tree. A binary heap is always complete binary tree, meaning all levels are fully filled except possible the last level, which is filled from the left to right. This is what heap property. Next one is heap order property. In a maximum heap, every parent node is greater than or equal to its child node. In a minimum heap, every parent node is less than or equal to its child node. It's all about the heap properties. Next, we move on to the applications. Before we go into application, we need to learn why we use a heaps, like improve the efficiency and priority queues. Heaps provide an efficient way to implement the priority queues like that. That's why we need to use heaps. Next, we move on to the applications of binary heaps. The heaps are used in binary heaps are used in the priority queue and heap sorting and graph algorithm and memory management like that. And in a priority queue used in scheduling a algorithm and simulation where you need to manage the tasks based on the priority like that. In heap sorting, a comparison based sorting algorithm that uses a binary heap. Next one is graph algorithm used in algorithms like Dijkstra's prims for efficient minimum spanning tree and shortest path calculations like that. Binary heap operations. There are two operations in binary heap. The first one is heapify up, second one is heapify down. And what is the purpose of heapify up? The heapify up operation used to restore the heap property. This is all about heapify up. How it works? After inserting a new element at the end of the heap at last the position, the heap property may be violated because the element might be greater than the maximum or smaller minimums than its parents. It's all about binary heap or heapify up. And next we move on to the heapify down. What is the purpose of heapify down or bubble down? The heapify down operation used to restore the heap property. After removing the root element, typically the element with the highest priority in a maximum heap or the lowest priority in a minimum heap. It's all about heapify down. Next we move on to the minimum heap algorithm. This is an algorithm for minimum heap. First we need to insert an element, add the new element at the end of the heap, perform a heapify, compare the inserted element with its parent, then swap if the inserted element is smaller than its parent. Repeat until the heap property is restored or the element becomes the root. Next, remove the minimum element, remove the root or minimum element, replace the root with the last element of the heap. Perform a down heapify. Compare the root with its children. Swap with the smallest child if the heap property is violated. Repeat until the heap property is restored or the element has no children. This is all about minimum heap algorithm. Next we move on to the maximum heap. The maximum heap algorithm is first we need to insert an element, add the new element at the end of the heap, perform the up happify, compare the inserted element with its parents, and swap if the inserted element is larger than its parents. Swap if the inserted element is larger than its parents. Repeat until the heap property is restored or the element becomes root. This is next is all about insertion operation in here maximum heap. Next we move on to the remove the maximum element. Remove the root maximum element. Replace the root with the last element of the heap like child or leaf node. Perform a down happify and compare the root with its children. Swap with the largest child if the heap property is violated. Repeat until the heap property is restored or the element has no children. This is all about maximum heap. This is all about minimum heap. We move on to the how minimum binary heap how minimum heap works. Let's take one example to show how minimum heap works. First, I am taking a like 5, comma 1, comma 4, comma 10, comma 20. This is my list. First, we need to create a complete binary tree. First, we need to create a complete binary tree. This is the how to create binary tree. First, I inserted 5. Next, 1, 4, 10, then 20. This is a complete binary tree. I want to create a complete binary tree. Next, we need to begin from the first internal node from the bottom. Next, we need to begin from the first internal node from the bottom. So we check 1. So we check 10. 10 is less than 1 or 10 is less or 1 is less than 20. Yes. So no need to change. This follows the minimum heap property. So we check 1 is less than 10, yes, and or 1 is less than 20, yes. So no need to change. This follows the minimum heap property. Next, move on to the next internal node, that is root node 5. Compare its child. 5 is less than 1 or 5 is less than 4. No. So this is not follow the heap property. What I need to do is, instead of swap, I need to swap 1 and 5. I need to swap 1 and 5. This become 5 and this become 1. This follows the minimum heap property. Next element 5. The 5 parent, it follows the minimum heap property. Yes, it follows the no need to do anything. No. We get the minimum heap is 1. 1 is the root node. This is the smallest element in the array. So this is the root node and next 5, 4 and 10, 20. This is all about minimum heap. First it begins from the leaf node. It compared with its parents. Is less than the child? Yes. So no need to do. The parent is greater than child. So we need to swap it. This is all about minimum heap. Again we need to apply maximum heap property with this example. This is the binary tree, complete binary tree. I am applying a max heap. 10 and 20 are the leaf node. First start from the leaf node. In the leaf node, which node is contains the maximum value? Here 10 and 20. I write here 10 and 20. 20 is high. So we need to compare with parent. We need to swap 1 and 20. In the 1 place we need to write 20. In the 20th place we need to write 1. Next, now this is follows the heap property. So next move on to the next internal node, that is root node 5. Check root node 5. Now in this 20 contains the maximum heap. So I need to swap the root node and 20. The parent node 5 is less than 20. So I need to swap with 20 and 5. In the fifth question I write 20. In the 20th position, 20th node, I need to write 5. Now this is not, follows the heap property. So we need to check 5. 5 follows the heap property? No. So I need to swap 10 and 5. In the place of 10, I need to write 5. In the place of 5, I need to write 10. In the place of 10, I need to write 5. In the place of 10, I need to write 5. In the place of 5, I need to write 10. Check 5 follows the heap property? No. So I need to swap 10 and 5. So this is my maximum heap. 20 is the highest value or highest node. So in the this is the root node, 20 is the root node. Next 10 is the parent of 5 and 1. This is the right child of 20. Every nodes can follow the heap property. So we get this heap number from this list. This is all about maximum heap. If you like this video, please don't forget to subscribe, like and share and comment in this video.